Hello, everyone. Thank you for joining us. My name is Dhanashri, and on behalf of IIT SoCal Alumni Association, I'm delighted to welcome you all on in this webinar session for AI Fundamentals Crash Course. This is the first event of the three-part series. Thank you for joining in. So before we dive in, I would just like to introduce IIT Alumni Association of Southern California. We are a strong group of 3,000 alumni from over 23 different IITs. We are growing exponentially, and we are like a strong knit group of inspiring leaders, technologists, entrepreneurs, and investors. And and we have had an amazing 2025 so far. So we kicked off the start of the year with three-part series with Shashi Tripathi, where we learned how to, convert an idea into a scalable company. We learned about how to create, like, how to launch an idea, how to create pitch decks, and how to create a very strong GTM strategy. Followed by that, we did a hugely successful DeepSeek webinar event with four amazing speakers: Tushar Khan, Ashish Bansal, Kaushal Mishra, and our own superstar Smita. And after that, we also hosted a very powerful masterclass on startup on valuation on startup valuation with Ravi Bhagwan and Abhi Mukherjee, who are, I think, here with us today. And we also did a very amazing annual picnic event in Cerritos, where we had like an entire day with fun activities during the day. So I think we have had like amazing events so far, and we are continuing to do the same. So we have many amazing upcoming events for you. So there are, like I mentioned, this particular AI series is a three-part series. This is the first part of the entire series. The second will be like around July 12th, where we will learn, we'll use the concepts that we learned in this and get a little deeper into the AI concepts. On August 2nd, we are having a LinkedIn strategy session where we are learning from our speaker how to become an expert in your own domain. And on August 16 will be the last part of the AI webinar series where we'll sit down and create something like prototype an actual AI tool using just AI and nothing else. Yeah. And I think with this, I just want to, add one more thing that, if you are still not in our LinkedIn or our WhatsApp group, please use these QR codes to join and be abreast of all the events that we have in plan for you. I think I'll hand it over to Weber. Weber, please take it over.
Good morning, everyone. My name is Vaibhav, and I will quickly take you through the house rules and introduce our esteemed speakers for the day. Uh, Quick house rules for today. Recording notice: this webinar is being recorded and it will be available soon on the IIT Alumni SoCal YouTube channel. So if you miss anything, you don't need to worry about anything. You need to stay muted. I would request all the people who've joined to kindly remain muted during the presentations and use the Q&A section to drop your questions. Question and answer time: Smita and Parag will be answering all your questions during and at the end of the session. So I would request you to keep the queries coming in. Now it's time to introduce our esteemed speakers. Parag Havaldar. He is an Oscar winning technologist and innovator in computer vision and machine learning with more than 25 years of experience driving groundbreaking research and development at Blizzard Entertainment and also a lecturer at USC. A true pioneer in performance capture and AI driven animation, Parag blends deep academic insight with real world impact, a rare combination of genius and humility. And last but not least, Smita Bagla. She is a managing partner at Amrit Ventures, a visionary business leader and startup strategist with more than 20 years of experience scaling tech, media, and healthcare ventures. Smita brings a rare fusion of Silicon Valley savvy and global perspective, with a proven track record in accelerating innovation and building bridges between entrepreneurs and investors. a powerhouse of empathy, insight, and execution. With that said, let's get ready to dive into today's masterclass. Over to you, Parag and Smita.
Thank you. Thank you, Vaibhav. And Parag, would you also like to
Thank,
unmute yourself?
yeah, agreed.
So, welcome everyone to this AI fundamentals or overview classes. We call it like the first introduction to AI. And we would like to start with a poll with you guys to understand how you feel at this time. So, Dhanashri, can we have the poll?
I think 56 people answered. Should I end the poll?
Yeah.
Okay.
So, can we show the results of the poll?
Yeah, could you not see it? I shared it.
No, I see it, but for the people. Okay. So
Yeah,
we
every-
found that 7% are saying they are kind of apprehensive, and 23% are somewhat comfortable. 11% are very comfortable, and most of you, 59%, are saying excited to learn more. So we will try to gear our talk based on these parameters, and we have an interactive Q&A sessions in the middle as we cover some topics. So we will go through that. And next slide, please. So Parag and I will go through this overall. We'll touch upon these kind of things in this, but we may skip some based on what questions we get. Or if you want to know, then after that, we can also answer those questions in Q&A. Parag, do you have anything to add here?
Yeah, I mean, depending upon your questions, we can definitely dive deeper into some topics or, explain whatever your interests are. But I'm really happy to hear or see the poll that a lot of people are excited to hear more.
Thank you. Next slide, please. So what is artificial intelligence? Artificial intelligence really is a big field of, is an entire field of study, just like physics. And this AI, machine learning, generative AI, everything is a part, a subfield of artificial intelligence, just like thermodynamics is a part of physics. So we started from pre-programmed instruction-based computer applications to machine learning, deep learning, and then we came up to the computers with generative models, large language models that teach us to learn and think. But so from glorified calculators to computers that can think, everything is artificial intelligence. Next slide, please. Oh, and here, this is the progression of AI. This is a very quick walkthrough of that right now also, and up till now, whatever we have seen is called artificial narrow intelligence. And it is the only one that we have been able to realize and we work with. It's also called weak AI, but it is focused from one narrow task to all the complicated tasks and mimics human behavior based on set of parameters. Our earlier examples were like Ask Jeeves, Siri, Alexa, all the drones, robots, IBM Watson, and now also the self-driving cars, the chatbots, everything that you see that OpenAI is coming with, like autonomous AI agents, everything is still artificial narrow intelligence. But we are getting nearer to artificial general intelligence. What is artificial general intelligence? It is when the computers can logically think, learn, and reason, just like a human, right? So that's our cognitive behavior. But it is still theoretical. It's the theory of mind. We're coming very, very close to it with our reasoning models and other applications that are flooding our internet right now. But it is still not realized. So some of the realistic but hypothetical examples are like we have a CEO assistant that is like the best chief of staff ever and thinks about everything for the CEO, or a self-teaching AI scientist, or even an AI caregiver. And you can imagine somebody like Data from Star Trek, or Jarvis from Iron Man, those series. So it's still fictional, and it's coming. And this one is known as strong AI. And then we have this wonderful in the clouds artificial superintelligence. That is when it's still theoretical, and that's when the computers will be self aware. It'll be intellectual beyond the human intelligence scope. There'll be highly developed thinking, and the hypothetical examples are cure all medical, artificial superintelligence, so all the cancer treatments, or everything. They'll just come up with new ideas. An ethics and morality advisor, or global, AI manager, just like we see in movies that AI is the one, the entity in the last Mission Impossible and other movies that is coming. It is totally, totally theoretical. Or even Lucy from a long time ago, that is still a Lucy movie I'm talking about, that is still self-aware. That's not available right now. So that is the current setup of ANI, AGI, and ASI. And so what I'm showing there in the diagram there is that we had rule-based programs and apps that were the earlier examples that we are all very used to, IoT and stuff. But with the machine learning and deep learning is the other part of ANI, where deep learning is part of machine learning, and discriminative AI means when you give it information and label data and supervised, non-supervised, all the terms that you've heard, but it is trained. That is discriminative AI, and you still can go back and find logic to it. Generative AI is the thing that has been developing and has got everybody's attention now, and large language models, and we'll talk about it in the next slide. Those are the ones that's also part of machine learning, deep learning, and that is what's making big advances. Next slide, please. Parag, to you.
So, to give you a historical time, I mean, the excitement today and getting to understand where we are going tomorrow, we also need to understand what has happened and how we have got to where we are today. So in this historical timeline, we tried to show that there are 4 different blocks. They're the early 1950s and 60s with the Turing test, and actually the Dartmouth conference in 1956, when the actual term artificial intelligence was coined. Then the second group of second column shows you the probabilistic AI in the 1990s and 2000s, where the IBM machine playing chess against Kasparov became very famous. The backpropagation algorithm, which is the core foundation where all these models work or are trained. There was the MNIST data set, which made handwritten letters possible to be understood by a computer. And there was a beginning of deep learning. The modern AI in the 2010s brought about AlexNet, and this was a big win in the artificial intelligence progress. Before then, there was a database of images, which was called ImageNet, and this had about thousands and thousands of images, all different ontologies of airplanes, birds, people, and there was always a competition when you had to, at any conference, the best paper results would give you how much they could recognize in images, and it was always 6 to 7 to 10 to 15%. With AlexNet, this went up to 60%, and that was a big breakthrough because of deep learning progress. And then came the area of starting to form generative models with generative adversarial networks, where it was a competition between giving an image and a character trying to distinguish whether it's right or wrong. And then 2017 was a game changer again with transformers, which has led to the GPT generative pre-trained transformer revolution. And now finally in the 2020s, we have come to the generative foundational models, They started with BERT and GPT-2, and I think in 2020, GPT-3 was one of the biggest advances, because for the first time, all these were started to go not just from the computer science community, but became known to people all over the world. Followed by that, we had now not just large language models, but also transformers operating on image models and video models to create Midjourney and DALL-E. Then there was GPT-4, and now in 2025 we have multimodal modal models with Gemini, Llama 4, and world models, which is trying to create a understanding of how the world is and behaves, not just through geometry, but also through simulations, and to create really fantastic videos that you're seeing in Veo 3 and Sora now. Next slide, please. So here are some definitions for starting from the basics to go up all the way to intelligence. In order to understand artificial intelligence, I think we should give a good definition of what intelligence is. So there are four definitions here I want to touch upon, which is data, information, inference, and intelligence. And these definitions, even if you ask professionals, they really stammer at coming to exact examples of what these mean. So data is just bits and bytes. If I give you, let's say, 80,000 bits in a stream and ask you to make sense of it, there's no way you can make sense of it because you don't know what the structure of that data is. Information comes when the data is organized. So if I tell you that those 80,000 bits are now organized as eight bits or bytes each, you know that there are 10,000 bytes in there. And furthermore, if I tell you those 10,000 bytes are organized as a 100 by 100 matrix, and each byte is actually a gray level pixel, then you know that this is now an image, which then can be represented or rendered on your screen. Inference is when you can take that information and come to some analysis of it. So for instance, you might know that in an image there is a person, or there is a dog, or there is an animal, or a car. So you're making an inference from that information. And intelligence is when you make use of such inferences to inform you about a decision that you want to take in the future, which you may or may not have encountered before. So this is what all of us exhibit. All humans exhibit. Some maybe more, some maybe less. But the intelligence is what really drives us to perform in this world. So artificial intelligence then becomes trying to do the same things computationally. And the area of artificial intelligence, as Smita had outlined, is made up of machine learning, which is trying to use lots and lots of data to come up with intelligent decisions, and another model of deep learning, which is really using neural networks to come up with an understanding of how to make decisions. So if you go to the next slide, you'll see, here's the problem that you're trying to solve in AI. So let's take any signal that you and I want to be aware of or interact with. It could be a paragraph of text, it could be an image, it could be an audio sound. And I've taken an image out here, or two images, and you want to find out or write a computational program that takes this image as an input and generates either a text description of what is in the image. So for instance, in the left, you can see that there is a baby crying, possibly because it's hungry, sitting on the lap of a mother and wanting to drink milk. On the right, you see a cat, which is playfully on a table and has dropped a plant and is about to drop a glass of milk. And these things are very hard to computationally figure out. Although we as humans, when you look at this, it's very easy for us to understand. Or you want to generate a sound that goes with these images, like a baby is crying, or there's a crashing sound of milk dropping, or you want to generate maybe a video of what is going to happen next. Or maybe you want to create a 3D representation of this environment so you can, a robot can interact with it and do necessary things. So these are the class of problems that the whole intelligent computation domain is trying to solve. So if you go on to the next slide. So in the old school, on the top, you see that all the computer scientists in the world were trying to approach it by writing explicit computer programs to find out what is there in the image, which means rewriting a sequence of statements that takes an initial state of pixels, processes them through if, then, else, or for loops, or whatever you want to, whatever computer instructions you want to give it, and ultimately comes to a output text. And this was a very, very hard problem. But now in the intelligent world of computation now with deep neural networks, you want to create an implicit computer model. And let's forget what the model is. I've shown a network to represent it out here. But the way that you want to solve the problem now is to give it lots and lots and lots and lots of examples, which may be supervised, as in knowing what is there in the image. If you feed it like a string of images where you have lots of babies walking, crying, playing, and tons of those images with descriptions. And then through this process of showing it, you train the model, it learns on its own, such that when it's shown a new image which is never seen before, it can come to the result of what is there in the image. So next slide, please. So let's take a pause here, and maybe based on this initial descriptions that we have given and basics that we have seen, have some questions that you might have, and which we can take.
Any questions? I think everybody's comfortable right now. Dee, Weber, are there any questions?
Oh yeah, I don't see. Yeah, I think Shaku has asked a question. How much data you need to train?
How much data do you need to train? But that really depends on what you're trying to achieve. For instance, ChatGPT was trained on all the data in the world, all the textual data in the world, and also images in the world. And it takes around 1 month of processing time on almost 4,000, 5,000 GPUs to come up with some, deterministic trained results. So really, the more data you give it, the more it can learn. So it really depends on how much of data you can collect. That's the main part, is data collection. Is where do you get your data? And that's why you find that most of the famous models of generative AI or in any kind of models, they are the good ones come out of places like Google, Facebook, because they own all the data.
Great question. So we just touched upon just a quick overview as to giving you just a taste of what artificial intelligence, historical context, and we are now. So let's now move on, if there are no more questions, to
Nita, there
what.
are two questions.
Okay.
There is one question from Monica. She says that you've mentioned multimodal models. Can you describe on what are those?
Sure.
Can we
So,
discuss it when we show them, or?
let me
Go
just
ahead.
answer one question. Well, in one sentence. So multimodal models are models that take into account different modalities. Like, for example, you want to take into account speech along with an image, along with sound, and then make a intelligent guess as to what to do next. All right, I think we can continue
Right.
then.
So there's, I think, one more last question by Asha Joshi. Sorry, it's by Aman Man. He asks, how does one determine whether to use simple old school computation versus generative AI?
So right now, everything complex that you want to solve is going to be using neural networks and generative AI. In fact, in the olden days or in the recent days, if you go to any conference of research, all the problems are solved using generative AI techniques or some neural network techniques, but using lots and lots of data. So that's safe to say that you might need to know how to program in order to get ahead, but being able to use these generative models and training them and being more expert in them is going to be the future.
I I
Right.
see a question from Asha Joshi, and she's saying that she recently asked MS Copilot to help write a new verse to an old emotional song, and it came up with something quite emotional and relevant. Was that AGI? So, Asha, this is still highly, highly, just the edge, sort of an example of ANI still. It is coming close to AGI, but it is not AGI. Parag, would you like to add anything more to it?
Oh, I think you said it. AGI, artificial general intelligence as human behavior, this is not yet, it's still hard to achieve. But in terms of like, what you've pointed out, it's very, there are certain things that we humans do, which we think are very intelligent, but they're actually not, like language. It's just a bunch of patterns. It's not randomness. It's a bunch of sequence of patterns that follow certain guidelines and rules. And we'll show you some examples of how GPTs work and, which can generate things like what you're saying, an emotional song to an emotional script.
Right. And autonomous AI that you see right now, what OpenAI and everybody's coming out, it really, really makes us feel that this is AGI and it's thinking on its own and the way it's responding. But unfortunately, it's still weak AI. Good for us, right?
And there's another question by Abhi. Given that current AI systems primarily rely on specific forms of logical reasoning and pattern recognition, what additional cognitive capacities or architectural advancements are required to achieve the artificial superintelligence?
So that's a great question. And I think one thing that is happening in the current systems is which is not which was necessary for intelligence or super intelligence is the fact that you have to interact with the environment to be able to understand it and respond to it. And unless we come to that level, in fact, no, let me tell you a short one, short description of how humans became intelligence. We life began in the sea right beneath, like at the bottom where there was no light. When organisms started becoming bigger and bigger, they started to develop sensors of pressure to move around. And then they moved to areas of light and they developed sight and it has to interact with the environment. Fish then started to walk as salamanders onto ground with mobile and they started to interact with the environment. Ultimately, you know the story to how they got to monkeys and then humans. So it was so what I'm trying to point out is intelligence is evolutionary, and it's evolutionary because you interact with the environment and you become better at things and explore things. And unless we have capabilities like that or models like that, it's going to be very hard. And it's coming. I mean, if you see what Gemini robotics is doing, robots are becoming really, really smart at doing exploring environments now.
So I think we should move on to the next. Okay, thank you, Tanushree. So based on whatever you had heard up till now, you heard large language models and neural networks as part of our ANI, narrow intelligence. These are just a couple of new terms that have come up. That is basically what are large language models? They're a type of artificial intelligence technology that is that can communicate in normal human language. And the picture over there basically shows that whatever you input in it and how, based on the analysis, it comes out as question and answers of like sentiment analysis and everything. But it is doing everything with pattern recognition using deep learning and as well as human reinforcement. And that is why, and with lots and lots and lots of data, and one a data set that is also trained and reinforced by human intelligence, by human eye. So it responds at light speed because the computational power is really available. So these are large language models that are available from different companies. And what are neural networks? A neural network uh, is not just, it is a machine learning model inspired to mimic a human brain. And it's how the biological neurons work in our brain. It is just like a child learns to walk and talk from a little age to going up to the older age and they know the whole language. That's how the neural network is simulating and mimicking the biological neurons, and it learns. and it remembers. And so it's very similar to it, but it still does not have the the capacity for emotions, or it's pretty much all the things are changed into numbers, and those numbers are then changed back to like text, image, audio, video. But it is learned. It's learned just like a child would learn. And training of what is right and wrong, we have to do by human reinforcement learning. So, in neural networks, there are a lot of concerns, and that is that we need to be sure there's no bias and others. So, can you go to so these were just terms, couple of terms that I've introduced, and then we'll say why we would introduce them. Parag, would you like to talk about the different neural networks architectures, and then we can
Yeah.
go to generative AI?
So this is following probably Avi's question also, is what kinds of neural architectures exist and where do you need to go with new architectures? So if you're a newbie in machine learning and want to get to know what architectures exist and what they are used for, here are some of the main ones. The first one is a fully connected multi-layer network or a multi-layer perceptron. These are normally the things that are used in most of the common networks. Then there are convolutional neural networks, and these take as input mostly images and try to make sense of what is there in an image. There are deep reinforcement learning networks, which is basically a way in which an agent works with an environment to create an action and gets rewarded if it's right or penalized if it's wrong. And through the reward penalization process, they learn to become super experts. And these are some of the agents that are better game players than even humans. Then there are RNNs. RNNs are very famous, or recurrent neural networks, because they are designed to understand specific patterns. These were the beginnings of machine language translations, or language translations from English to German and so on and so forth. And all these exist uh, 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 in the beginnings in 2010, 2012, 2014, until the generative pre-trained transformers started to come in. But recurrent neural networks are normally for understanding patterns. And this is a favorite one of mine. Autoencoders, a variation of autoencoders, because these were the ones that started the generative whole world. So the idea there is to figure out what is the entropy of the information that you can get and design it in a very low level space called the latent space. And then you operate on the latent space to generate, high dimensional outputs of various kinds. Uh, I talked about generative adversarial networks before, and these are very, competition oriented. You generate a result, and there's a discriminator that tells you what is good or bad, or how bad it is, or how good it is. And it's a self-learning network. And these GANs were the first ones which, they became famous because of the generation of deep fakes. They allowed for deep fakes to come out. And the last one is GPTs. And we're going to talk a lot more about GPTs in the next few slides.
Thanks, Parag. So, this hype, and as we are talking about that AI has been, and you heard about all the different networks and architecture and the historical concept perspective of it, that they have been there since the early 2000s, and we have been working on it. But a step change happened in 2022, as Parag had also shown, is that more than just analyzing or classifying data, the generative AI or the GPT-3 models could now generate something entirely new. And entirely new, like text, images, audio, even synthetic data, they did not have, they could mix like very, very fast at a computational pace. They could generate new content based on whatever they had learned on. Okay. So introduction of GPT-3 in OpenAI in 2022, it brought AI to the most basic users. One really did not need to be tech savvy to use it. And it was something that everybody could use to write better, create better, and they could get detailed, collated, complete answers to their questions in one place instead of going and saying, so now what, Google give me that, or Yahoo give me that. So adoption for that in first week was 1 million users. So all of a sudden, this was like a big thing. And as AI has been coming, it's been growing exponentially. So just a mental picture of it is that along with GPT-3, you have to see that you have an access to a smartest person. To me, that's Einstein. That's why Einstein is there. Who ever lived, and he's a combination of all smart people you've ever met. Okay. And with this, it's always at your disposal. It never runs out of patience, and it can explain to you anything. But just like humans, it can also misunderstand if you don't ask it clearly. It can understand it. If you ask just a small question that's very generic, it will give a generic answer. But it depends. It's if you ask a very detailed with all the kind of prompts, all kind of details, then it would give a better answer by researching its patterns that it has had and all the data that it has had. Again, it can only return based on what was given to it. So it all depends how effectively you communicate with him. So just like Einstein, it's very powerful, but you have to ask. It's like having Einstein and you ask them to do a high school report instead of Einstein and solving big problems, right? So the possibility of what you can do with this GPT-3 and then on has just improved exponentially. And but along with great power comes great responsibility. Next slide, please. GPT, this Gen AI has serious limitations. First of all, it cannot apply critical thinking, so it may present to you misinterpreted information. So one has to be very careful, right? Because depends upon how it was trained, it can have biases. For example, like, if it was trained on data that was pre, say, 1950s, and women were not in the work, so many, like in the work pool. So it could, if it was trained on that data, it could always, like based on the gender, it would say this person will not be a good fit, right? So similarly, based on what data is given, it produces your answers. So you have to take it with a pinch of salt. Then, because it creates new data from the combination of rearranged content, so if that data has not been provided to it, if the latest thing is not in its training, even though the latest models are all training in real time, it can give you some old information because it doesn't have capacity for original thought. So, and sometimes they are not explainable how it got to it. But like Perplexity explains how it got to it, what it showed. So it's becoming better, right? And it does not understand that it is breaking the rules or thinking outside the box. That is a human capability, human intelligence capability to come up with alternate answers. It tries to do very well based on the data it has, but it cannot think like, cannot do exactly as a human can do, as a trained human can do, or as a learned human can do, intelligent human can do. So those are the limitations. The mitigation strategy is to be responsible and take it with a pinch of salt and establish some governance. Again, there could be some security breaches, so you have to be sure that you increase access controls. And you should also double check when it gives the information. You need to cross check if the information that you got is really, don't take it as word of God or word of law, right? It gives very good information. It may still be 95% there. Okay. And there has been this thing called RAG, retrieval augmented generation, that does iterative, and it connects to reliable knowledge assets to be able to generate better answers for it. And so current models are very reliable, but still you have to take them with a pinch of salt. Next slide, please. So Parag talked about generative pre-trained transformer, right? And what we have, that since then we have had like so many GPT-3 models or GPT models, GPT-4, GPT 4.0, they have come, that has flooded the screen. And how has this happened is because there's like emergent technology that has happened. So small models are like John Fell, and if you see on the right side, it says down, it will put that in. But large model can do basically role play, poetry, code, etc., and generate strategy. It can teach, it can code. It can provide you with legal media, right? So it can do all that. But the reason for emergent capabilities, we say, is that the unexpected novel behavior that you feel that, oh, how it did it, those are the capabilities that's why people, there's been such a big adoption, because our brains, like, except for like Einstein's brain or Shakuntala Devi's brain, cannot compute these things so fast. And these models, they differ by speed, by capability, by cost. And some are downloadable, some are open source, while others are specialized and integrated. But they can all do things that they can take from text and go directly to text, or you can input text, images, audio, video. So if it goes from text to text, it's single modal. If it is images to images, again, it's single mode. Audio to audio, video to video, all those are single mode, just one to one. But when it takes everything like text, images, audio, video, and then also can produce something that is compiled of everything, it's known as multimodal. In a very basic sense, is what I'm explaining here. So what I would say is that this is why people are thinking about that AI is now much ahead of them. Okay. But again, you have to take it with a pinch of salt. Parag, do you have anything to add in here?
Oh no, it's right. I mean, it's very exciting what's happening in the world today. So let's all be aware of all these multimodal capabilities and start playing with them.
Next slide, please. So the comparison of GPT models today, these are the ones, if you see, originally the ones that came out, the size was smaller, the memory capacity was smaller, the accuracy was less than 60%. That is in 2022. And input formats were just text and speech, and the price was pretty high at that time. Then we moved on to GPT 3.5, and when I say GPT 3.5, it is not just OpenAI's, it is the generative it is the GPT models of different companies, like Parag had said, and I had shown, is like Llama and Gemini and all those, right? And so those are the ones. Then we see that it has been improving. 3.5 accuracy was still 60%. But now, today, because the size is so big and the memory capacity is enormous, it is greater than 80% accuracy. And it takes multimodes, like all the input formats, and the price is like super right now, but it is because of the competition with China and others that it is coming down in price. Next slide. And these are the latest generative AI tools, like, the in 2025, what people are using. And you can use these tools to do content creation or do visual arts and designing, coding and development, and audio and video generation. The coding and development ones are really fun because you can give it in English as to what you want to do, and it spools out a code for you that you can sort of understand with Python. And we'll have our great computer professor show us how to do all those things. And so, but the basic things that we can also show you today is to do the chat GPT, how to start using the generative AI tools. Next one. This is just an example, is that initial example, like if you give it an image and says, what happens if I use the scissors? Then ChatGPT analyzes that picture, and based on its patterns and whatever it has, it can come up with an answer that really makes sense. So you should use it, but use it with caution. Next one. So over to you, Parag. Would you like to show ChatGPT?
Sure. So let me share my screen. Okay, so what we are going to do next is show you a running example of a query in ChatGPT, and this should be, uh, I'm sure most of you have tried something, but let's try to see how you want to prompt ChatGPT. And then after that, I'll do something a little bit different, which is actually go into how GPT works and show you how it gets trained and show you what happens after training. So let's start with a prompt. So if I say something like, tell me your story, it's very generic. There is no tone, there is no audience, there is no topic. It will tell you something very generic. So the more specific you get with the prompt, the better you're going to get. So now, for instance, if you say, tell me a short science fiction story. Now we've got, some specific genre to it. Still not very specific, but then it starts telling you a story which is going to be what you ask for in a science fiction story. But then if you tell it something more specific, like say,
tell me a science fiction story of a superhero.
So this was tell me a story of set on Mars of a lost robot and a mysterious signal, and then it starts generating something more interesting. And the more specific you get, the better it is for your answer. So next, I'm going to ask, write a 300-word science fiction story on Mars. So it's specific with the number of the word content as well, the number of words that you wanted. So it's going to give you more. But one thing you have to notice that every time I asked this, it didn't improve on the previous story. It gave you a completely new story. So that's one thing. And by the way, if you want to ask it, what is a good prompt to test ChatGPT? Give me an example of a bad prompt and how to get better at it successively. See, it gives you how to use it also. Anyway, so that's an example of ChatGPT. Now what I want to do next is actually show you how ChatGPT works. So I might be a little more in the weeds, and this might be a precursor to what might come in the upcoming lectures. But I'm going to open up Python box, and let's get some libraries installed. And I'm going to get a trained model with all the words on Wikipedia. Can you guys see the font here? So while that model is loading, let me show you how ChatGPT actually works. So here is how it works. In ChatGPT or in any GPT, you give it a sentence and it tries to predict the next word. So what would you say the next word is for the first sentence? There was a famous tennis legend from Germany who had a great serve, and his name was Boris. It should predict Becker, right? And here's another sentence. The Ukraine war began in 2022 when England's Prime Minister was Boris Johnson. And somehow it has to figure out what is the next word because it's still Boris, but what is the next word? This is based on context. And that's what all the GPTs do. They work on probabilistic predictions based on context. So for example, here is how ChatGPT would work. It would start with, there was a dash. It would predict what dash is. It would be famous. And then the next word, tennis, player. And it could make, it's a probabilistic choice because depending on the context, it will get some choices and it'll take the next word that makes the most sense. So in this case, instead of, Germany, it picked Switzerland, and then whose name famous was maybe Roger Federer. So that's how it predicts, right? And context defines everything. So here are 3 sentences in which the same word mole has a different meaning depending on the context. So there were holes in the garden made by a mole. So the holes and garden each tells you what mole is in this sentence. And 235 grams make 1 mole of uranium. This should bring you to Avogadro's number because that's what mole means out here. And in many cultures, it's considered a mark of luck and even beauty to have a mole on your face. And that's a totally different kind of a mole, right? So how does a GPT know what mole is being referred to so that it can predict correctly. And to get into a little bit more, you need to understand about embeddings. So here is a sentence, and each of these each of the words out here, when it goes through GPT, are broken up into what we call tokens, right? And these are normally, it's a little more complex than just words, but for the time being, let's just say every word is a token. And these tokens are then given embeddings, which are solved for, the values are solved by through a training process. Now here, I'm giving you examples of what their means as a vector of, in this case, about 30 words in the model that I'm showing you. But in like GPT-4, for example, every token is a vector of almost 12,258 words. And every embedding has some context. And you can imagine that in this vector space, which is a 12,500 vector space, the dimension, it has to learn something. And I'm going to give you an example of that. But basically what happens in a GPT is that it wants to predict the next word. So it needs to get an embedding for it. And through various contexts that it understands, it tries to predict what the next numbers are going to be. And then finally, it comes at the end of a series of context evaluations, it comes up with an embedding for the next word. And that next word embedding could be maybe call, it could be the word home, it could be the word get. So this really depends on what it has learned from the other contexts. So this is how GPT ends up predicting the next word. So let's do one thing now. Let's see how this all works in a certain sense. So I have increased the loaded the model of all the words on Wikipedia, and they have been pre-trained to get a 50 number embedding for any word. So for instance, if you take the word woman, it's got an embedding, right? And these are just numbers that it has learned through pre-training. And what I'm going to show you is probably going to be a little bit of a eye-opener if you get into the weeds. Here is the model for a man, right? But somehow it has learned that the difference between a woman and a man, which is just a difference of two vectors, is some numbers, right? And if you see the length of this vector of the difference between man and a woman, so I'm going to type some linear algebra evaluation, which is basically finding out the length of the vector between the difference between a man and a woman and a man. This comes out to be 2.6. And what is shocking is if you find out the difference between mother and father, it's almost similar. If you find out the difference between niece and nephew, and that's bizarre because somehow in this 50-dimensional space, it has learned what steps to take to change gender. And this is how, and this is one thing that we all can understand and associate with, because I can give you, several examples of not just gender but also weight or mass or any property that we know of. But here is what was an eye opener to, and this is something probably you will appreciate. So Japan also has a vector. Germany also has a vector. So if you do the same thing of what is the difference between Germany and Japan, right? This also has a vector and its length is 4.92, but somehow it has learned through all its training that the difference between sushi eaten in Japan and bratwurst eaten in Germany is also the same length. Or any food, for example. And this I find very fascinating and bizarre. So the things and the dimensions along which it learns and the way it learns, it's something which is really hard to understand. All right, so with that, let me stop sharing. And
Can you guys see my screen?
yes,
Okay. I think we went into this. So yeah.
so let's take a poll again to see, now that we've seen how GPTs work and how, what generative models are. Um, let's see what, if your answers from before changed. Okay. So I think from the last time, there are still people who are apprehensive. There are people who have become more comfortable, and there are, I think, more numbers who are excited to learn more. Nice. So let's take a break for some Q&A. And if you want to also unmute your mic and come and ask questions, that's also fine.
I think Asha Joshi, yeah, her question was answered. Abhi Mukherjee, do you want to turn on your mic and camera and ask the question?
No, my question has been answered and in the perspective. But yes, it's a long conversation I think I would like to have with Parag offline. So thanks, though.
Okay, sure. Dr. Ram? So,
Now,
Dr.
I can ask my question quite. It's a much more generic question. It's got less to do with technology and a lot to do with the way people make decisions in the ethics area, where it really has a phenomenal combination of culture, religion, upbringing, and ever so many other complicating factors. And that may be the reason why in your initial classification, you had said it goes to almost the highest level of AI. I just was kind of musing over that.
It is so Dr. Ram, basically we're saying that ethics is extremely important, because when something is allowed to run amok, then it can really do a lot of damage. So ethics and governance and responsible AI is something that one has to take care of it all the way, but it goes also to the top, to the super intelligence. Does that answer your question?
We need a much longer discussion on that, and I don't want to take
Absolutely.
everybody's time.
Ethics is
It
is a
is.
big one.
It's a big one, yeah.
Shreya? So she asked that, when you say accuracy of GPT-3 is 60%, what are you referring to?
So when these are the statistics we have taken from other, from like, Turing, and if you see that anything that we've taken from somewhere else, we have given the source at the bottom as to where it was taken, this information was taken in, as this is a teaching class. So in that, they are the ones who have done the accuracy measurements. At that time, in 2022, the whole accuracy of the information returned because it took time for the GPT-3 and others to get more real. It wasn't real-time data that they were looking at. It was the computational power was slow, depending upon if you had a free version or if you had a paid version. So the accuracy or the amount of information that you can get from it was less. So Turing had indicated that it was 60%, it was around 60% when it started. It was still very good, but it was compared to what it is now, it was just 60%. Does that answer your question?
And also, like, it's the hallucination factor is what also determines the accuracy.
Yeah.
Okay. The next question is from Arun Karlamangla. Are you here?
I think I just answered his question.
Okay, sure. Okay. Mr. Ramesh Srinivasan.
Yeah. Yeah, I'm here. A quick question. So, understand AI tools, plenty of examples of it replacing human activity, right? Even human thought and all that. What are some of the best known examples you're aware of so far? A couple of them where AI tools have replaced B2B application business software. You know, the classic ERP kind of tools and various systems that are out there for B2B. Are there any examples so far of AI tools replacing them? Thank you.
Parag, do you want to take that?
Well, anything that was mostly rote or can be done with a lot of data, those are the first ones which you will see a transition. To give you specific examples, for example, all the
Transaction systems, though, Parag, create data, right? These are transaction systems
yeah.
that create the data required. But go ahead, please. I won't interrupt. Go ahead.
No, my thought process is like, if you see things like uh, even like from the simplest things like doing your taxes from accountant to even and this might not be B2B, but I'm going to go as high as trying to understand images of or X-rays or CAT scans for radiology. All these are seeing significant improvements in how computational processes will actually replace things. So it's not B2B. I think I need to get more into maybe we should have an offline connotation of businesses.
Sure. Thank you. Yeah.
And I think we are going to touch upon it in the next one, but we do have like how businesses are being affected by AI and how are they leveraging it. So we have it. This is not part of the AI overview or the fundamentals, but it is something we didn't think that it should be we can discuss it on either WhatsApp or LinkedIn, and we can continue that conversation too. Okay, next slide.
Oh, do you want to stop the Q&A here?
Oh, no. Whatever else we have. Yeah, sure. Sorry.
Let me know when to stop the Q&A, okay? The next question is from Dr. Sangeeta Srivastava. Are you here? Okay. So her question is, in healthcare settings where we stand ethic-wise when using ChatGPT, what is the accuracy when prompting info about complex conditions like total colectomy with K-pouch or just as simple as high protein and fiber diet sample? I found results inconsistent and hard to trust.
So yeah, you have to. So in healthcare or in legal or another, or even in basically anything that works with humans, you have to double check it and see if the results are right, because it is again coming back from whatever data it was trained on. So you have to see, and some models may be better at healthcare as opposed to the other ones. So one has to find out as to which one works in the industry much better, as well as is it giving you? You have to double check it with human reinforcement, basically, to be sure that it is doing well. And then you can add your own data to train it so that, it gives you the right results. So you can add examples of what has gone through your areas and train that GPT to be able to train that model to give you better results. Parag, would you like to?
Smita ji and Lois, very wonderful presentation, and thank you for answering. And I'm here. So my idea is that what large language model would you recommend being particularly feasible and most trusted in healthcare settings? So do you think ChatGPT 4 or that would be much better? Any particular, I know you can't emphasize any one particular, but any particular model you would recommend.
I think from what we've seen, most of the large language models, GPT or anything, Llama or Gemini, these are really good at understanding rules of language, and they have a lot of information that they're trained on, but they may not have specific domain knowledge that may be applicable to the domain that you need. And so if you want to make the same set of rules that a large language model is providing to answer a specific domain, there is something called, as Smita was discussing, RAG, retrieval augmented generation, where you provide the same model a set of different knowledge bases where it can then go and understand how to correlate all the information in that knowledge base and give it to you in a understandable manner.
Thank you.
We do have a lot to cover. Can we refer to the other questions after the quick presentation? Is that okay with everyone? Okay. Unless anybody has one question we can take if anybody has something that they would like to ask right now. Okay. So one of the things we're talking about is, why is everybody suddenly thinking of AI? Wherever you go, everybody is saying, oh, I'm doing AI. Even the automation tasks that they used to earlier do. I think my video is not on, sorry. Okay. 1 second, please. Something went wrong over here, so you'll see me sideways from the other camera. So when we had the electricity happen, for example, it took a long time for people to get used to it, and then they started working on it and they started understanding it. They had the time to react to it. Similarly, we had other wheels and cars and everything happened, but people could react to it. So, and they could get skilled in it and they could work on it. It had a long time, and it would take 10, 20 years until it became part of our lives. But now, even though the GPT models and AI has been around, it was mostly for insights. It was mostly for recommendations and predictions. But now it's giving new data. And it is really, really increasing its capabilities at a very, very fast speed. So it feels like that the human intelligence is not catching up to it. But that's really not true. It's just that artificial intelligence capabilities are growing, given the computation capabilities, given the amount of data that is present, given how people are using it and what else they can do in order to make that thing smarter. Like, for example, if you are a doctor and you learned stuff in your undergraduate and then you wanted to specialize in it, and then you learn much better, much faster, because you have already learned the basics. So when you go to the master's course now, you know that you are specializing and becoming better. Similarly, artificial intelligence is just growing exponentially. It's an extremely fast revolution. And you see that it seems like that AI, or the robots in this picture that is from Henrik Niebuhr, he said is like that it's our turn to rule the world. But human is getting scared and said, we have had this for 300,000 years. Hey, slow down. But we have to change according to the pace that the technology is increasing right now. Any questions on this? Or so how do we respond to it is basically based on our mindset. Is either you deny, say, ha, AI can't do my job, it can't think, I'm a graphic designer, it won't come up with this, or I am like, say, I'm a creative person. Yes, it can't do some of those things. And then the companies think, oh, we don't have time to go into it. But that time is past. AI will not take your job, but people who know AI and leverage AI will end up taking your jobs because they can leverage those to do faster and better jobs. And and then there is a panic that AI is going to steal my job. We will go bankrupt. So both of those, denial and panic, are not good responses. You have to have the positive mindset. Is that I will learn AI, and what will I learn is that this is not that hard to do. It's still my assistant. It is still something I can leverage, and along with me, along with when I'm powered with AI information, when I'm powered with this Einstein, then I will be insanely productive. And the companies that are responding. So it's like the positive mindset. So our question is the human role important in this age of AI? As the AI capabilities improve, when I say X, it's like you can substitute it to the doctor, radiologist, many, like any of the roles that a human is doing or any of the work that human does. So next one, please. So how do you deal with it? For me, it is that I ask ChatGPT itself. I work as X. My biggest challenge is Y. How can you help me? And then AI will say, is like my colleague or my assistant will give me the answer. And I would learn for that. Even when learning initially the AI part, I asked ChatGPT, what is the fastest way to learn ChatGPT, right? So it is something you can ask, you can provide context, you can do legal, you can ensure that there is data security, legal compliance in there, and decide what to ask and how. Okay. Next one, please. I just want to say this, and is that a bad, like when Parag demonstrated the prompts, this is called prompt engineering. It's not really engineering, it is how you ask questions. So the more clear you are, you ask better. Suppose you just say, give me an agenda for a workshop. Like Parag said, give me a story. It gave whatever, right? And it gave like an agenda for workshop, but it gave a very generic agenda. But if you ask a better prompt, like, or you iterate and say, give me an agenda for a workshop for leadership training, and then it will give you better answers. Or if you say, give me an agenda for a workshop for leadership training, feel free to ask me any clarifying questions. What are the things I should consider? The more you give and the more you iterate, it learns from that. So we can also add it, like Parag was saying, that it is not going back and it's giving new stories at a time. But if you say is refer to the old story that you just saw, that you just provided, and iterate it to give me a better answer, so it will give it to you what you need. So again, this is a very, very fundamental way of looking at it, but this is for the people who are just getting started with AI. So the better prompts you do, the better results you get. And I found the side benefit is that we develop better communication skills because we become clear at asking the right questions and how to converse. So by getting better at prompt engineering also makes you a better communicator. Okay. So that's something I have. Parag, would you
No, I
add
think
to
you're
it?
right. Yeah. I mean, prompting is is an art. You have to know what you want and detail it. And also the the industry I work in, text prompts are one thing with which artists never like. They want to have prompts given through interactive graphic designs and motion where they can make things move uh, with a motion prompt.
Okay. Next slide. Okay. Parag, would you like to take this current state and what's coming?
Yeah, this is another big uh, there are lots and lots of things to discuss here. So I'll just mention a few things on what's happening currently in the industry. Generative models are increasing and they're going into different multimodal ways. So for instance, Text-based models are being used very prevalently now, but image-based models or models that create video, models that create entertainment, these are also coming up in a big way. Um, and in terms of how we respond to it, this is very important. Um, the other thing discussion I was having with some of the other computer scientists the other day was, where do we go with this? I mean, so the next step of progress is going to come in the form of agents. Uh, Agents are smart, computational models that take all these AI techniques and automatically work with each other or with humans to be able to accomplish complex tasks. So, for example, if you want to go to a vacation to, let's say, the Netherlands, right? You just give that prompt, or you ask the AI agents to do it. What's going to happen in the future likely is, American Airlines are going to have their own agents. The airlines are going to have their own, the car rental companies are going to have their own agents. Maybe the hotels chains will have their own agents. And these agents, given your constraints and your inputs, will talk to each other automatically, and they'll figure out the best possible vacation that you can have on the days that you want to go. And that's an idea of where agents are communicating behind your back, so to speak, but coming up with constructive solutions for the tasks that you want. And then you ask, okay, what's going to be beyond agents? When will all this, where will it end? What are the things that you want intelligence to achieve in the end? Practically speaking, that's what I think that all the computer scientists and the people working in this field should do, is take a very bold step and try to generate all intelligence of humankind available to anyone's fingertips. So in other sense, there are doctors in the world, there are uh, all kinds of professions in the world. If you can harness all that knowledge into a model and be able to query that model on your phone to be to have access to all that information, that's certainly a big step that that engineers can do. But
So
anyway,
I
there are
can
lots of
add,
things. Yeah, add to that.
yeah, I can add a little bit to it, is that this is Stanford's latest AI 2025 index report. And what they're saying is that, it is demanding benchmarks, continues to, it continues to improve. And business has become like, businesses have really taken on the AI, because they're seeing what they can benefit from, what they can automate, and that's where they're going. And one thing that Stanford says is the US is still leading in producing top AI models, but China is closely coming together with DeepSeek and others. So the responsible AI system is evolving, and global AI optimism is rising. That's all. Any other? Okay, now Q&A.
How do you want to do it? The Q&A? Do you want
People
to?
can ask their questions if you want. We have how many? We have 10 minutes for Q&A.
Mhm.
Like
Okay.
9 more minutes left here.
Samir Penkar. So Samir Penkar has asked this question, like, how do you folks keep up to date with the pace of development?
It is hard because there's lots and lots and lots of things happening. So the best way, uh, one good way to do it is to make sure that you divide and conquer. You have your friends and students or whoever you can have access to, go and explore different areas of progress that are happening and come up with a summary, and see how you want to collate your information and explore what you want to explore. But it is hard. Smita, what do you suggest? How do you keep up?
It is just basically you have to see what your needs are and what the companies that you're working with, their needs are, and then keep learning, keep like there's so many podcasts available. There's so many new, on Twitter, on Instagram, on others. There's so many AI latest developments that are appearing. So to keep up, one has to be apprised of those. And you can also set up some alerts. for yourself. So that's how I keep up, because it's the, oh, Elon Musk is talking about this neural neural AI that, and other things. So on this podcast, or somebody else is talking about, like Sam Altman is talking about it at some place, or so that's how we are keeping up with it.
The next question is from Roop Goyal. When will we have hands-on exercises?
In the next session.
Thank you.
Okay. The next question is from Aman Man. Who pays for the computation power for every query?
So they're tokens, and Parag can explain in more detail, but basically when you pay, you are assigned, when you say like a $20 subscription to ChatGPT, you assign a total number of tokens, or what your queries and others combine to, and how many tokens you use. And based on that, you are paying for that, or the companies are paying for that, and they get a different rate from these companies. So the computational power is all in the, in the servers that are around the world. And that's how you're paying. And if you want more, then if you use a free version, you run out of tokens very, very fast. But if you're using a paid version, you have a lot. And Parag, do you have anything to add to it?
No, I mean, the current business model around how you are charged is basically based on subscriptions, which gives you tokens to then use. But yeah, I mean, it is a computationally expensive process, not just to train a model, but also to use it, because every time it's the same. Whether you ask the question about, who is the president of the US, or where you ask is what is the most unsolved problem in mathematics, the computational cost is the same. And that's another, crazy thing, because to answer who is the president of the US, you don't need that much of computation compared to what is the most unsolved problem in mathematics.
Yeah, as the nerds use it, they use it differently. And most of our audience today are engineering nerds, and we use it in a better way, yeah. But there are people who are writing beautiful poems, like Asha also wrote, and she's a big investment banker, but she is the one, like, she wrote about these emotional things, and you can do all that also at ChatGPT, but the computational power is always there. Yeah.
Um, Hari has a question. He says that there are talks that AI will eat up a lot of jobs, and also AI is going to create jobs. Keeping this in mind, is AI going to create more jobs or eat up more jobs?
I
That's
want
for
to
you, Smita.
no, I want to answer a funny one. Remember when we had when automation came and the DocuSign and document things came, people started thinking we'll be using less paper, and we will not be using paper. But then everything came, we use double the paper with the printers now, because anything you sign on DocuSign, you also print it out and you keep it because you want the validation, you want to have those. So it's just a different way. We didn't imagine that we'll be using so much paper earlier, right? When it was just paper, there'll be one place to sign. Now there are multiple places to sign. So in my view, it is that AI will sort of like reset the landscape a little bit. People will not be doing those automated repeatable tasks, because that's what will be automated, but they will come up with more creative, more power, more things to do. And again, you always have to double check, right? You always have to use it as to where you can make these autonomous agents, where you can give it a work and say like fraud detection and other things can happen automatically, and you don't need people for that anymore. But you will have, what kind of it can't do, because GPTs cannot still do, like, on their own thinking. So humans will still be needed. It's just be different kind of jobs that will be available. That's my take. Parag, now you add.
I think jobs are definitely the landscape is definitely going to change. Um, and one of the examples I think I'd like to give is in the 1980s and 90s, ATMs came. And with ATMs, you didn't have to go inside a bank to draw out cash, right? So the question then was, tellers are going to be replaced, or they're going to lessen, the jobs of tellers are going to go. But what happened was actually the contrary. tellers grew 4 times in number.
Exactly.
And why did they grow in number? Because now the banks had opportunities with ATMs to actually build more banks in communities, and have a bank just around the corner for anyone. And as a result of which, the number of tellers required increased. So it's going to transition into some other form. And then, but I also like to want to address this question from a long-term thought: is AI and all these tools increase productivity, and unless productivity becomes infinite, there is no threat to jobs.
Great. The next question is from Vivek Gupta. How do you decide on which LLMs to use?
The latest one.
That's a hard one. It also depends on personal preference. So, like, I use four, like, for me, when I'm doing content, then I use 4 different NLMs. Like, you saw all the list of it. When I'm doing design, for example, it also depends on personal preference. You like what they provide. They're pretty much, you can also test it out. You ask the same question from different LLMs, and whatever you like better, you can start using it. I usually use 2 or 3 at a time to get my answers, and then I create a content based on that. So again, I feel that that is your personal preference, but most LLMs are that we showed you here also, or if you Google and say the top 25 LLMs or the top LLMs that are available in 2025, you will be able to find which ones you want. And depending upon the work you want to do, you can choose whichever LLM to use.
Okay. Sorry. Yeah, please continue.
No, I'm done.
I can add a little bit to that.
Yes,
I mean,
please.
so Chat GPT from OpenAI definitely has a lot of branding to it because it was the first one that came out, and it's been used by many people. But if you see, equally powerful are Gemini from Google. And I think 2 weeks ago I attended a keynote where Llama 4 was released, and Llama 4 has a very different architecture of experts running in parallel and then collaborating at the end to give you the best possible answers. So that's another one that you should try.
And it's
Llama is
free.
Llama is from Meta.
Yeah, but and it also doesn't require you to pay for it right now. So people use it more. Yeah.
So, Smita and Parag, we are at 12:30 mark. So let me know, do you still want to take more questions? How many questions do you want to take? How do you want to do it?
If
I'm
the
okay.
audience is interested, I don't mind waiting for some time.
Yeah, me too.
Okay, cool. All right. The next question, let me see.
I can answer Shaku's.
Yeah, sure. Please go ahead.
Shaku is asking that I don't see any tools that replace things like Epic. For people who don't know, in healthcare, Epic is like an all-inclusive program that manages everything for your, patient charts and doctor notes, and it is the main program being used in hospital. Shaku, you're asking about that one, right?
No, actually, I was kind of answering the B2B question by Ramesh Srinivasan. So I appreciate you picking that.
Okay, no worries. Then that's okay. Then we don't need to go into it. So
No.
Okay, thanks. Go ahead.
The next question is from Dr. Ram. I see his camera is on. So do you want to ask your own question, Dr. Ram? Oh, okay, I'll go ahead. So, do you see any
Can you hear me?
Yes, I can hear you now.
Oh, wonderful. Yeah, I mean, this is a fascinating discussion. Both Smita and Parag, as expected, are doing a very, very interesting job of making us even more curious to know more about this. But the kind of applications that come to mind, which I don't know when, at what point of time will AI be I mean, I see based on what Parag told us, AI is going to, nature of job is going to largely change into expert prompters. Better the prompter you are, more of an expert you are in a particular subject, more likely you're going to come up with more productive answers to many of those questions. The difficulty I see and it came about when I was writing my book on ethics, is there's a whole bunch of things we have no clue, and eventually we have to make value judgments. So that's where I had a question for both of you, is there are two situations I can see. Ivy League admissions, for example. Do you see any point of time where AI will completely replace the admissions counselors? Possibly not, because of the value system they use. And likewise, when it comes to things like sustainability or any environmental issues, there is a whole bunch of value judgment, especially things like value of life, and there is an externality involved. Those are very, very difficult questions to answer by just logic. And I was just wondering, do you see AI moving in any direction that might help us, or is it something too far away?
I can start by answering. Let me take a dab at your first question. So your first question, I don't think we as a community should be thinking about when is something getting replaced. I think our goal should be, when is a task getting better and more productive as a result of all these tools. So in your example about Ivy League college evaluators being replaced, maybe the process will get much more faster, better, and resulting in better quality of students and education, because now you're able to like process instead of 100,000 applications, 2 million applications in a much more qualitative manner. Regarding let's take your second question later. Smita, you want to add to that?
No, you're right now. That's fine. Please go ahead.
And your second question about value and judgment and which requires true intelligence and capacity from an emotional level, from a organizational level, from all different viewpoints. We talk about artificial intelligence today, and I've given you examples that although we're calling it it's just simple computation in a way that has never been done before. I don't believe it's still intelligence. And so in that capacity,
there's a reason I asked that particular question. When I was doing this analysis, I looked at what kind of value of life do different cultures in different countries put in their decisions on how they set up regulations, for example. Amazingly, very wide range of them, all of them came up with nearly the same value of human life. That completely shocked me. And I thought it is just because one was copying from the other. And I see AI largely doing that. Or can AI do something different?
AI can do something different, because what the models are doing is taking snippets of everything they have access to, and interpolating it in between in a very high dimensional space. And so in that regard, it is going to do something different. Whether that something different is right in your judgment, or if that's a totally different question.
Thank you so much. Yeah. Okay. We can talk offline on this a little more. I need to learn.
Sure. Would be very happy to.
I'm sorry, the Ivy League admission staff question, Dr. Ram. I know I said I didn't have anything to add, but something came to my mind. Ivy Leagues are looking for really exceptional people. It's students in general. So, and that also includes soft skills and different things. So I will not think that their admission staff will be replaced. It could be reduced, but there will still be people who would be evaluating the different things other than just general capabilities of people. They will rank them, but it would go.
Sure. Yeah. Thank you.
The next question is from Dr. S. Sudhakar. So, if you were a crystal gazer, what human skills, existent or non-existent, do you anticipate becoming more important with the growth of AI?
That requires a big discussion as to what we need. And it's different for different people, I would say. And One is that one should learn how to leverage tools in order to be able to. That is important with the growth of AI that people should do. Just like now, 90% of the people know how to drive cars. It's like there are some essential tools people need to learn. But crystal gazing into the future, it is very hard to predict right now because it's growing so exponentially. Parag, your view.
That's a hard question to answer. I mean, not just from these tools that are, but if you see um, how these LLMs and these processes overall are improving multimodalities for robotics. I mean, you can take, we are just interacting with computer systems out here, but think about a robot that has access to understanding language now and can perform and react in the real world to simple queries like, make me an omelet or get me a glass of water or whatever it is. Then you start seeing how life can really truly change. And what skills you will require at that point of time, I think that only time will tell.
The next question is from Aman Man. A recent MIT study showed that GPT reduces brain activity. How does one balance it, especially as we begin introducing it to the kids?
Just like you balance video games and TV time and give them some activities they have to do. Like, I'm just going to like very young kids. And for college kids, yeah, Parag, please go.
No, I love the opposite opinion. I think, like you mentioned, with great responsibility comes, with great power comes responsibility. I think we should teach them responsibility with these tools and with these things, and not encourage them to create shortcuts for themselves, but also encourage them to create a better output the best output that they could have, that they can do with this.
Yeah, absolutely. And like I feel like video games also teaches kids, for example, how to respond fast, how to think quickly. So there are some good aspects to both having them the screen time and the like using AI and not using. So you're right that we need to give them like, the parameters of responsibility that they need to have. Does that answer your question, Aman? It's a big discussion again.
I think the next question is pretty similar. So I think he's setting the precedent for it. Like, do you guys think that overall critical thinking skills of humans would decrease as we get more and more dependent on Gen AI?
I'm going to take the opposite point. I think they should only increase. I think the human connection between people and between people and machines is also going to increase. And this is going to lead to I want to say, different and maybe somewhat better life for all of us. But yes, I mean.
Hi, can I just add on to my question? Hey, Smita, hey, Parag. Nice presentation. Thanks for informing all of us about all the recent advancements. So, Parag, are you in academia as well? So yeah, I'm from academia as well, and this question actually comes down to teaching and forming assignments and how students um, like formulate their thinking. So earlier on, like when we didn't have a lot of these GPTs, we used to spend a lot of time on thinking how to solve a particular problem. But nowadays, if you just enter that problem into ChatGPT, you don't have to think anything, right? You get a step-by-step response on how you need to think. So my question is just like, will we still be able to develop those kind of critical thinking skills, or like problem solving skills that we used to have earlier? Or it's more about the future students or the future generation of students, or are they going to be completely dependent on Gen AI? So if I ask a question to a student, are they going to just open their ChatGPT on the mobile and then going to ask that question to the ChatGPT and then look for an answer? So that's where like I'm asking this question for.
Yeah, great question, because we often, as educators, we often think about how things should change, because you still feel education should be relevant, education, university should be relevant. And the few comments that I can make are on the one side for instructors, it is a time to think of how you want to not only uh, see how to use these tools, but also maybe change the way you're designing your assignments, um, making things not that easy or not that not it's hard. But I can tell you that whenever I at least design assignments or started to design assignments now, I often go to ChatGPT to see what the answer is, and then that only teaches me to make it more difficult. If this is, and you iterate on it, and thereby you add more value to the assignments that you're giving out today. And the other thing about you said about about basic skills like math, programming, science, I think you can't depend on generative techniques to just spit out something and use them, right? Because I use some of the like some of the automated tools for programming because it just makes programming much faster. But if it introduces a bug, I need to still go and debug it. I need to understand how to debug it, and that would not be possible. And that's sometimes even much harder because unless you know exactly, it's like looking into somebody's code where you don't even know anything. So I would argue that you still need the basic skills, and you need to be better at the basic skills in order to be productive with these new tools.
Great. Thank you.
Well, I think in interest of time, before conclusion, I'll just ask Parag and Smita to just give a small intro on what's coming next, if possible, and then we can just conclude.
You mean what's coming next in our
In the next
series?
sessions. In the next sessions. Yeah.
Okay, next sessions. I think the next one that we are going to have is like, a one-on-one view of different tools that, and we can take like one content generation or multiple and see how you can compare it. But a demonstration of like 5 to 6 different tools that people can have hands-on on their computers too and work along with it. That is the main one. And then we might talk about a little bit about, how AI is helping in the businesses, like how different businesses can leverage AI. So that is what I believe we are going to be teaching. Parag?
I think we can challenge ourselves and ask the audience, what do you want to listen? What do you want to see?
Absolutely.
Yeah. No, but yeah, I think this was more introductory about giving you the jargon, the different tools that are available, how people are using it. And we went into some details about how they actually work, but maybe we can go into more details of how they work, more details of how to use them, and be more practical.
Sure. So I'll definitely pose these questions to, all the today's attendees and the future attendees that what do they want to see in the upcoming session, and I'll relay the information to you also. And apart from that, whichever questions were not answered in the session, we will ask, Smita and Parag to give us the answer, and we'll relay the answers to the attendees. So rest assured, we'll make sure all of your questions are answered. And thank you so much for to all of you for joining us today. We hope that this session was insightful and engaging for all of you. And this wouldn't have been possible without you guys, Smita and Parag. Thank you for putting so much effort into it. Like I've seen through the iteration that the content went through, and the only thing that they had in mind was how do we make it more better for all the people who are joining in. So you really see the cumulative efforts that both these guys have put in into making the content really informative for you. So thank you so much, Smita and Parag. And this is just the beginning. Like Smita and Parag mentioned, we have the next 2 sessions which are coming up, which would be diving deeper into the concepts that we are discussed, but not just that. We would also have hands-on exercises and hands-on activities for you guys. And if there are any content that you want us to cover in the topics, let us know. And before we disperse, I would really love to, have like a group photo of everybody who is in the session today. So if you don't mind, I would request everybody to just turn on their cameras and just say, like, just smile for some few seconds. And while everybody is doing that, I would request everybody who is not yet the part of our LinkedIn and our SoCal WhatsApp group to please take a look at, all the links that Priyank has shared to be part of our community. And apart from that, we are a volunteer-driven community. So if we would love to have any kind of helping hand in creating all of these events. So if you are interested, please message any one of us, and we will love to have you on board. So with that, let me just see. Okay.
Can you unpin us so then everybody
Yeah,
can?
I will unpin you. But I would love for more people to turn on their cameras. Okay, where did Parag go?
I'm here.
Where are you? Okay, you're here. Okay, I've removed the spotlights. Okay. Okay, I'll just click a photo. Everybody say cheese. 3, 2, 1. Thank you so much, everyone. Thank you so much. And
Thank you.
you will have the recording within by the end of the day or in 1 or 2 days. Thank you so much for joining.
And a
Have
big
a-
hand for
Thank you.
Dee and Priyank and Vaibhav for running this webinar. Thank you.
Thank you,
It was
Dhanushri.
fun
Thank you,
seeing you
Vaibhav.
then.
Great work.
Thank you.
Bye.
Bye,
Thank you.
everyone.